In the previous section, you learned about the accumulation and amount functions, where little a of t is the accumulation factor from time 0 to time t, and capital A of t is the accumulated amount in the account at time t. Simply put, the amount, capital A of t, is the initial investment times the accumulation factor. The accumulated amount consists of the initial amount plus accumulated interest, so that the definition of accumulated interest for a specified period is simply the difference in the account between the amount at the end of the period, which we will call t, and the amount at the beginning of the period, t minus 1. Capital I represents accumulated interest, and it's equal to capital A of t minus capital A of t minus 1. Now, the two most common ways to accumulate interest are compound interest, which uses the effective rate of interest, and simple interest, which uses the simple rate of interest. We will explore both of these methods in the next few slides. Using simple interest, we accumulate interest over t periods linearly by adding I of the principal t times. This creates an accumulation factor of 1 plus it, and an accumulation amount of the initial principal, which is a of 0, plus the interest t times, and the interest is equal to the initial principal times the interest rate, which is I, a simple rate of interest expressed as a percentage. Now let's look at an example. Alex deposits $1,000 at Bank Simple. Bank Simple credits Alex a 5% simple rate of interest annually. Alex holds the money in Bank Simple for 10 years. How much interest has Alex accumulated over the 10 years? And how much total funds are in Alex's Bank Simple account at the end of those 10 years? So first, let's look at the accumulated interest. As we discussed, accumulated interest is the principal times the interest rate. And we add all of that together for the number of periods we're accumulating, which is 10. So that we have $50 of interest every period, and we accumulate it 10 times, so that we have a total interest of $500 that's accumulated over the 10 years. In terms of total funds, we're going to use that total accumulated interest of $500. We're going to add it to the initial principal of $1,000 to get our total fund amount, which is going to be $1,500. When using compound interest, we accumulate interest over t periods by adding I, or the interest, of both the principal and interest accumulated to date t times. So that in each period, interest is added based on the outstanding balance at the beginning of that period. This creates an accumulation factor with an exponent of t, or 1 plus I to the tth power, since every time we're multiplying the outstanding balance by 1 plus I. And the accumulated amount is the initial principal times the accumulation factor of 1 plus I to the t. So in this case, I is an effective rate of interest expressed as a percentage, as opposed to a simple rate of interest. And now let's look at an example. Alexa deposits $1,000 at Bank Compound. Bank Compound credits Alexa a 5% effective interest annually. Alexa holds the money in Bank Compound for 10 years. And the question is, how much total funds are in Alexa's Bank Compound deposit account at the end of those 10 years? And how much interest has Alexa accumulated over the 10 years? As you can see, in compound interest, it is easier to first calculate the total funds and only after calculate the accumulated interest as the difference between the end of the period accumulated amount and the beginning of the period accumulated amount. So let's take a look. In order to calculate the total funds at the end of the period, we will use our accumulated amount equation from the previous slide. Our initial principal is $1,000, and we're going to multiply that by 1 plus the interest rate, the effective annual interest rate of 5%. And we're going to take that to the 10th power, so that at the end we have 1,000 times 1.05 to the 10th, which gives us $1,628.90. As you can see, this is a much more potent way of calculating interest and accumulating interest than the simple interest way, since in simple interest we had a total of $1,500 at the end of 10 years, and with compound interest we have $1,600 plus in our bank account. And again, this is because under compound interest, we not only accumulate interest on the initial principal, but also on the interest that was accumulated to date. So again, the accumulated interest for the whole period of 10 years is the end of the year accumulated amount of $1,628.9 minus the initial amount at the beginning of the 10 years, which is $1,000. So that over the 10 years, we've accumulated $628.90. This slide attempts to show how simple interest and compound interest accumulate differently over time. As you can see, simple interest is linear. It is the accumulated function of 1 plus IT, so that at the beginning of the period, you have just the initial principal, and over time, you constantly add on IT to that initial principal. This creates a linear function. Compound interest accumulates exponentially. As we see, the accumulated function under compound interest has an exponent of t, so that it grows with 1 plus I to the tth power. For periods of less than 1 year, the linear function is actually greater than the compound interest function. And we can see we accumulate more interest if we use days or months that are less than 1 year to accumulate interest. However, once we are accumulating interest over more than 1 year, the compound interest equation starts to increase exponentially and exceeds the simple interest linear line. So oftentimes, simple interest will be used in financial products that expire in less than 1 year. Otherwise, compound interest is the most popular method of crediting interest. Since compound interest is the most popular method of crediting interest, the effective annual rate of interest is a very important concept in the FM exam. So let's spend some time with it. So the effective interest rate, I, is the interest rate that's used in the compound interest accumulation. It is defined as the amount of interest earned over 1 year divided by the value at the start of the year. And that is a very important concept. The effective interest rate is the amount of interest earned over a period of time, or 1 year, if it's an annual rate, divided by the value at the start of the year. In notation terms, it is the accumulated amount at time t minus the accumulated amount at time t minus 1, which is the interest earned during the period. And that interest is then divided by the accumulated amount at the beginning of that period. Let's look at an example. Alexa's deposit account at Bank Compound had a value of $1,400.77.46 at the beginning of year 9. At the end of year 9, the account had an accumulated value of $1,551.33. What effective annual rate of interest did Alexa earn during year 9? Again, it's important to note that here we're looking for the effective annual rate of interest and not the accumulated interest amount. So in order to calculate the effective annual rate of interest, we will take the end of the period accumulated amount of $1,551.33. From that, we will subtract the beginning of the period accumulated amount, which is $1,477.46. That will be a total accumulated interest amount of $73.87. And then we will divide that accumulated interest by the beginning of period accumulated amount, $1,477.46. When we do this ratio, we get an effective annual rate of interest of 5%.